It's another demonstration related to photoelectric effect. This is a vacuum tube. At the ends of the vacuum tube there are two electrodes, negative electrode and positive electrode. The negative electrode means that end is connected to the negative terminal of the battery. Positive electrode means that end is connected to the positive terminal of the battery. And here there is a microammeter to measure the current flow. Microammeter measures very small current. It measures in microampere. So we are using a microammeter to measure the current flow. And the cathode is a photosensitive material. Photosensitive material means when light falls on the material, it will eject electrons. So we are allowing the light on the photosensitive material. On the photosensitive material, light is allowed to fall and the electrons are ejected. These electrons will move towards the anode. And these electrons will move to the anode. So cathode is a photosensitive material. When light falls on the cathode, the electrons will emit and these electrons will move to the anode. Because electrons are negatively charged, these negatively charged electrons are attracted by the anode and the electrons will move through this circuit and we can measure the flow of electrons and we can measure the current in terms of microampere. So it is a demonstration related to photoelectric effect because here we are allowing light to fall on the photosensitive material, that is the cathode, and the electrons are ejected from the cathode. So that is photoelectric effect. So this demonstration explains how the photoelectric effect works. Here we are discussing the wave theory of photoelectric effect. The wave theory of photoelectric effect was a complete failure because that theory couldn't explain photoelectric effect successfully. First failure was intensity problem. According to wave theory, when the intensity of light increases, the kinetic energy of the ejected electrons also increases. However, experiments shows that kinetic energy maximum is independent of intensity. So according to wave theory, the intensity of light depends on the kinetic energy of the ejected electrons. That means when the intensity increases, the kinetic energy also increases. So according to the photoelectric effect experiments, the intensity of light has no effect on kinetic energy of the electron. That means if you are increasing or decreasing intensity, there will be no effect on photoelectric effect and there will be no effect of the flow of electrons. Second failure was frequency problem. According to wave theory, photoelectric effect should take place for all frequencies. However, experiments on photoelectric effect reveal that for every metal there exists a frequency below which no photoelectric effect. According to wave theory, photoelectric effect takes place for all frequency. But experiment revealed that for every metal there is a particular frequency below which there will be no photoelectric effect. And that frequency is known as threshold frequency or cutoff frequency. But wave theory is saying what? Wave theory is saying for every metal, for all metals, the frequency is, for all frequency, the photoelectric effect takes place. But it is not correct. Experiment shows that there will be a particular frequency for every metals. For each metal, there will be a corresponding frequency. Below that frequency, there will be no photoelectric effect. Only above the frequency, the photoelectric effect takes place. But wave theory says what? For all frequencies, photoelectric effect takes place. It is not right. So these two are the two failures of photoelectric effect. The third failure is time delay problem. According to wave theory, there will be a time delay between the incidence of radiation and the ejection of electrons. That means when the light falls on the metal surface, there will be a time delay between the falling of radiation and the ejection of electrons. But experiments proved that Photoelectric effect is an instantaneous process. That means there will be no time delay between the falling of radiation and the ejection of electrons. Photoelectric effect is an instantaneous process. In 1901, German physicist Max Planck suggested that electromagnetic radiation consists of its packets of energy. It is a packets of energy. Each packets of energy is known as quanta. And the energy of each quantum of radiation is given by an equation E equal to hf. So each packet consists of energy, and the energy of each packet is E equal to hf. This is known as quantum of energy. So E equal to hf. E is the amount of energy in one quantum of that particular radiation, and that energy is expressed in joule. So E we are measuring in terms of joule. E means what? The amount of energy in one quantum of that particular radiation. F, the radiation frequency, it is measured in hertz, and H is the Planck's constant. Its value is 6.63 multiplied by 10 to the power minus 34 joule second. So E equal to hf, it is the energy of the packets of energy, and the packet of energy is known as quantum of energy. So electromagnetic radiation means it's a packets of energy, and each packet of energy is known as quantum of energy, and the energy of each quanta is E equal to hf. And E equal to hf you can rewrite in terms of c and lambda, because frequency equal to velocity divided by wavelength. You studied in the lower class, frequency equal to velocity divided by wavelength. So here the velocity or speed is the speed of the electromagnetic radiation. So in photoelectric effect we are allowing the radiations is electromagnetic radiation. All electromagnetic radiation has a frequency of 3 multiplied by 10 to the power 8 meter per second. Lambda is the wavelength of radiation. So there are two equations in terms of frequency, E equal to hf. Then in terms of wavelength, hc by lambda. So these two equations represents the energy of electromagnetic radiation. H is the Planck's constant, F is the frequency of light falling, c is the speed of light, that is the electromagnetic radiation, lambda is the wavelength of light. After the failure of wave theory of light for the explanation of photoelectric effect, Albert Einstein developed quantum theory of light, that is the particle theory of light. In this theory, the radiations we are considering as particle instead of a wave. So in 1905, Albert Einstein developed the quantum theory of light. Electromagnetic radiation consists of a stream of energy packets called photons. Energy of each packet, that means energy of a photon. Energy of each packet. Packet means photon. So here the radiations we are considering as packets of energy or particles, and this particle is known as photons. And the energy of photon is directly proportional to frequency. From one radiation to another, the energy of the packet or energy of the photon will be different, and which is proportional to the frequency of the radiation. So energy equal to hf. If you remove the proportional sign, energy becomes E equal to hf. H is the Planck's constant. The work function W0 of a metal is the minimum energy needed for an electron to be set free from the metal surface. That means for every metal there will be a work function, and the minimum energy needed for an electron, that means when a radiation falls on the metal surface, the radiation should have a minimum energy. The radiation should have a minimum energy to set the electrons free from the metal surface. So from one metal to another, the work function will be different. It is the characteristics of a metal. From one metal to another, the work function will be different. So the work function of a metal is defined as the minimum energy needed for an electron to be set free from the metal surface. So that work function is equal to HF0. F0 means threshold frequency. So the frequency is F0 is the threshold frequency, H is the Planck's constant, and W0 is the work function. So work function is written in terms of threshold frequency. So if the frequency is threshold frequency, the energy of the radiation will be work function. So if the energy is less than the threshold frequency, that radiation will not provide sufficient energy to release the electron from the metal surface, or that radiation is insufficient to provide the work function. So to make free the electrons from the metal surface, the radiation should possess threshold frequency, and the energy corresponding to the threshold frequency is known as work function. Work function simply is an energy. It's an energy corresponding to the threshold frequency. If the frequency falling on the metal surface is less than the threshold frequency, that radiation will not provide sufficient energy for the release of electron. So the work function is the minimum amount of energy required to release the electron from the metal surface. So work function is equal to HF0. F0 is the threshold frequency. So if the frequency is threshold frequency, then the energy falling on the metal surface will be work function. So from one metal to another, work function will be different.